Good morning, students. Today we'll start with 18FT 504, which talks about quality assurance in garment production. In this, we are at Unit 3, wherein quality assurance in fabrics and accessories are mentioned. We have already completed 3 lessons into this, and today we are at lesson 4, wherein we will talk about tolerance limits, quality standards for fabrics and other raw materials and accessories. Quality assurance of all these materials are required, but whether they are all perfect material or there is some tolerance limit, both from the point of view of the raw material and the accessories, that is the point of discussion today. So let us see, students, what are the different tolerance limits and quality standards are there for this raw material and accessories. As you see in the figure, there are a lot of accessories are there, like zippers are there, lot of buttons are there, some sewing threads are there, embroidery threads are there. So a lot of accessories are used in the garment. But before using such material, we have to first ensure that the quality of those materials are good. Okay, and there must be some standards, quality standards of those material in terms of performance, in terms of durability, appearance, all sorts of things. So let us see, students, what are the different aspects of these tolerance limits and quality standards. Now, when you are talking about raw material like a fiber from which the fabric is produced and garment in turn will be manufactured from this fabric. So fiber plays an important role to this total process of garmenting. That is the reason the labeling is required. When you are talking about fiber content label, now if there is only one fiber present in the apparel product, okay, then there is no tolerance. What do we mean by that? There is only one yarn has been shown here, so there is no other material is mixed with it. So it is only one fiber. So there is no tolerance in such kind of product. What is the example? You may ask, students. Example is nothing but a fiber content label which talks about 100% or all. Like the image what has been shown in the figure. The particular fiber which is present there, it is 100% cotton material. So it will be labeled as 100% cotton, and there is no tolerance in it. Now, students, you may ask, what is the meaning of this tolerance? Tolerance means that suppose 100% is the label, 100% cotton, but it may vary due to the manufacturing process. Some other fibers may be present into this. So is there any tolerance? Plus minus 1%, plus minus 2%, plus minus 3%. So such kind of things are talked about in the tolerance of the fiber content labeling. Now let us see, students, when you are talking about fiber content labeling, so if there is more than one fiber, okay, in such a situation, what will be the tolerance? So tolerance here is plus minus 3%. Now what do you mean by this? Plus minus 3%? Let's take an example that 65% polyester is there, in the product and 35% cotton is there. And plus minus 3% tolerance when you are talking, that means the polyester may vary from 62% to 68%. Similarly, the cotton, 35% cotton can also vary from 32% to 38%. So these variation is the manufacturing variations. There are various reasons are there how these tolerances have been worked out for different fibers, but internationally acceptable tolerance is plus minus 3%. When the fiber labeling is more than one fiber, sometimes in the label 3 fibers, 4 fibers are also present there. So equally this rule is applicable there, plus minus 3% tolerance. So that is about the fiber content labeling. Now when you are talking about the care labeling, as you might be knowing that in the care labeling, the washing, bleaching, dry cleaning, all symbols are there. Okay. And what are the parameters which are measured in this care labeling? So one of such parameter is dimensional stability. We have to focus on dimensional stability of care labeling, especially in washing and dry cleaning. Now what do we mean by that? Let us see, students, as you have seen already, maybe washing machine and the dry cleaning machine as shown in the figure. And when you are representing the dimensional stability, how it varies, the acceptable limit, tolerance, all these things we should discuss here. Now dimensional stability, when you are talking, we normally talk about shrinkage or growth. Okay. Normally shrinkage tolerance is there in different markets. When I am talking about the market, normally we talk about US market or non-US market. Okay. In the non-US market, there will be US, UK will be there, Canada will be there, then there will be Australia, there will be Japan. So all these other countries are there. So US and non-US based. Now in the oven goods, there are the variations, that is minus 3% to minus 4%. This tolerance is there. Okay, it may vary. Shrinkage may vary product for oven goods. And if it is in the plus side, that is the growth side, yes, it is plus 3%. Okay. So this is the tolerance in the international level for the oven goods. Minus 3% to minus 4% in the shrinkage side and plus 3% in the oven goods in the growth side. Okay. But this is the situation for the only oven fabric, okay, where warp and weft are involved. Now let us see, students, in the oven material itself. Suppose we are taking cotton. Yes, there is also the tolerance is there, plus minus 3% for this. Then there are tolerances are also there in different other fibers. For example, if we take the other fibers like blended wool, the tolerance is plus minus 2% into that. So dimensional stability, these are the international level tolerances. So blended wool is having plus minus 2% tolerance. Now let us see, students, any other kind of fibers also. Linen and viscose. So linen and viscose is having plus minus 4%. It is more. Okay. So this shrinkage percentage is acceptable for linen and viscose, irrespective of US or non-US based market. Okay. So these are the different examples what we have tried to quote of the shrinkage percentage or dimensional stability percentage. Now in case of the oven material, there are certain chemical fibers are also used. There plus minus 2% tolerance is given. Okay, chemically produced fibers, plus minus 2% tolerance is given into that. So that is the examples of woven material and their tolerance in the shrinkage. Now students, is it equally applicable, this kind of tolerance in the knitted material also? No, because you see the structure varies. In the woven material, there are warp and weft interlacement, and in case of knitted material, there are wells and courses interlooping. So that is the reason the tolerances are also varying. Now for the course and wells direction, irrespective of any market, whether it is a US based market or non-US based market, plus minus 5% in the shrinkage tolerance is there. Okay, so the which value you are getting there, plus minus 5%, it may vary. So that is the indication of this dimensional stability and shrinkage. Now this is the structure of course and wells in a knitted fabric, wherein this plus minus 5% rule is applicable. Now let us see, in the knitted material, there are other aspects are also there, different other structures and how their dimensional stability varies. From this table, really you can understand that how is the dimensional change, and these dimensional change is tested as per the care instruction given. So what is the washing method or what is the dry cleaning method applied, in that this kind of changes are there. So knitted material or the knit wear, here in this case plus minus 4%, coarse knit, they are little bit of higher, plus minus 6%, then ribbed material plus minus 7%, interlock material plus minus 6%. So these are the different standard for or the tolerance limit for dimensional change according to the care instruction of that particular fabric. Now let us see students, for the woven material how it is. As we have already shown you in different figures, and in the particular tabular form, if we try to compare, cotton plus minus 3%, the particular tolerance, okay, how it varies, blended wool plus minus 2%, the linen viscose blend plus minus 4%, and chemical fibers, whatever is mixed there, synthetic fibers plus minus 2%. So these are the woven material, okay, and there are certain cases, some embroidery, lace materials and hosiery materials are all there, where also the dimensional stability can be measured, but not is the point of discussion today. We have taken only the main material, that is the knitted material and the woven material. So students, you may understand now the dimensional stability and how it varies for different kind of structure and different kind of fibers when they are used. Now let us see students that in case of dry cleaning, what will be the tolerance? Can you tell students, is it the same as washing? No, because dry cleaning there is some solvent, okay, solvent is used in the dry cleaning, and in the washing you are using a certain amount of detergents. So woven products, when you are taking, and the dry cleaning tolerance, when you try to investigate, it has been seen that tolerance varies plus minus 2% to plus minus 2.5% for woven goods, where there is interlacement of warp and weft. So plus minus 2% to plus minus 2.5% is the woven product dry cleaning tolerance. Now in case of dry cleaning tolerance for the neat goods, little variation you can see, plus minus 2.5% to plus minus 3%. These are the tolerance limit for knitted goods in case of dry cleaning. In earlier case, what we have seen, that is in the washing as per the wash care instruction, and here as per the dry cleaning. So tolerance will vary. So here the knitted fabric, it may vary plus minus 2.5% to plus minus 3%. Okay students, then we will go into the next chapter or next test, that is called non-chlorine bleach test. What do you mean by non-chlorine bleach test and why it is used? Students, you may aware that there is a care level instruction in each garment. There some instruction about bleaching also is mentioned. In that, non-chlorine bleach is one of such bleaching tests. And non-chlorine bleach test, if anybody performs, then rating 4 if you achieve. So then the sample passes, because this is the United States care labeling recommendations. The rating 4 is acceptable. So in that case, non-chlorine bleach test is carried out. Now in case of the washing and dry cleaning rating, total overall scenario if we take for this, then it varies from 3 to 4 in general, irrespective of whether it is US based or non-US based marklet. So it varies 3 to 4 washing and dry cleaning rating. Now in case of spirality, students, you may be aware about the spirality because we already discussed in earlier lessons that spirality is nothing but the side seam twisting after washing or after manufacturing, or it is sometimes called as a torque in the fabric or the garment. So that spirality, if we check in different market, US based market or non-US based market, we can easily say that 5% is the limit for that, 5% tolerance. It may vary 5% in either direction, and it is acceptable in any market, whether it is a US based market or it is a non-US based market. So this is the spirality as is shown in the figure. So both for the top part and the bottom part of the garment, you can see that there is some twisting, side seam twisting or side seam displacement is there, trousers and the t-shirts. So in that case, the percentage spirality, what we will get, the deviation, it should not exceed 5%. So that is the rule for spirality or the tolerance limit for spirality measurement. Now students, what do you mean by this figure? So this is nothing but washing or dry cleaning, whatever you can say. Washing and drying also can be possible. Now there is one important terminology is used in this particular area of when we are really classify the garments as per their different functional properties. So DP rating plays an important role to it. Now students, can you tell what do you mean by DP rating? You see, DP rating is nothing but it is durable press rating. It talks about the surface characteristics of the garment or the appearance of the garment after wash. There should not be any creases, there should not be any wrinkle, it should be a perfect surface, smooth surface. So that is the DP rating. And what is the tolerance limit? Is there any tolerance limit? This durable press garment, the test which is carried out is called wash and wear test, and durable press rating of 3.5 is universally accepted, irrespective of it is a US based market or non-US based market. So, durable press garment, we should accept it with 3.5 rating. Any value beyond that, below that 3.5 is not acceptable, because the appearance will be little bit of doubtful into that. Means many creases may formed, wrinkles may appear into that. More than 3.5, yes, it is always acceptable, okay, because surface structure or surface nature of the surface is improved into that. So DP rating of 3.5, that's why it is universally acceptable rating for wash and wear tests, and DP rating which is applied for certain garments. Now students, let us see some rubbing fastness and the crocking fastness test. Now normally the rubbing fastness test is applicable in the EU market, and crocking fastness test is applicable for US market. There is only terminology difference, but methods are almost same, that rubbing the material, okay, with a dry or wet cloth. And in case of tolerance, the dry and wet staining is 4 and 3. This is universally acceptable tolerance, okay. So different phases of this rubbing or crocking test has been shown here, and how the particular staining has happened, that is also indicated in the figure. So 4 and 3 are the threshold limits for dry and wet staining. Let us see students some other parameters also. Now 3 to 3.4 or 3 to 3.4 in color staining is applicable for color fastness to perspiration and water. This is again universally acceptable in US and non-US based market. 3 to 3.5 or 3 to 3.4 in color staining is acceptable in international market. Now, when you are talking about the color staining, we normally talk about the multi-fiber fabric staining. In a piece of fabric, there are certain kind of multi-fibers are there in the order of acetate, cotton, nylon, polyester, acrylic, wool. And during the time of perspiration fastness and the water fastness test, the staining may appear in different kind of strip indifferently, because the nature of the fibers are different. So color staining acceptable rating is 3 to 3.5 in color staining in case of perspiration and water fastness properties. Now what do you mean by students? This is an example has been given how the color varies or how the color change takes place. This color change belongs to perspiration and water fastness tests. Normally various tests when getting carried out, example the washing test or perspiration test or water test, water fastness test. So there two items or two parameters are judged. One is the color staining to the multi-fiber and another one the change of the fabric color itself. So that is the color fastness to perspiration and water that is applied to it. So color change in the fabric after wash. So that has been depicted here. and here the color change rating is 4. This is again universally acceptable. So that is about color fastness to perspiration and water, and how the difference takes place between different fibers, okay, or different garments or different colors. So color change 4 is acceptable. Now color fastness, when you are talking, apart from this perspiration and water, there are other fastness tests also for specialized garment, okay. Now what do you mean by that, students? There are color fastness tests associated with chlorinated water and the sea water also, and applicable for swimwear and beachwear. And in this case, when a particular survey was conducted, it has been found that color fastness rating in terms of color change 4 is acceptable for both chlorinated water and sea water in US or non-US based market. Then different types of garments which comes under this category are covered, and if a garment fails to achieve that particular mark, that is 4, then the quality of the garment is not good. There will be color bleeding for swimwear and beachwear. So that color change rating of 4 is universally acceptable for this, while we are accepting the goods, okay, for color fastness to chlorinated water and sea water. Now students, let us see color fastness when you are talking the staining part of it, because as we have already mentioned that there are two aspects. One is the color change and another one is staining. So when you are talking about the staining for chlorinated water and sea water color fastness test, for swimwear and beachwear, there the staining part talks about that 3 and 3 to 4. 3 is acceptable, little stringent rule, and 3 to 4 little relaxed rule, non-US based market, and this is applicable for color staining part of swimwear and beachwear in terms of chlorinated water and sea water fastness. Now let us see, students, that what are the products. You can see in the image that some of the products which are used for swimwear and beachwear is shown over here. Now let us see, students, apart from that, whether any other tests are there or not, which is important for the garment industry. So one of such tests is color fastness to light test, CF to light we call it as. And this CF to light, inside the light fastness tester, there is a lamp called xenon arc lamp, and the xenon arc lamp, the radiation or the illumination, whatever is there from that lamp, is simulated the sunlight light. So that's why this xenon arc lamp is used inside the chamber, light fastness chamber, which may be air cooled or water cooled, any of them can be. So light fastness test can be tested for color fastness. Now what is the acceptable limit for that? Okay, for the innerwear, there is some specified regulation, specified standard or rating is there. Like lining and underwear, it is 4. So if light fastness rating, that is a color fastness to light, is 4 for lining and underwear, that means the quality of dyes used in the lining and underwear is good and it passes the test. But when it fails to achieve 4, what will happen, students? Yes, the sample will fail. So that is about this lining and underwear. in the light fastness test. Now students, can you tell me what is the type of garment has been used in this image? Yes, it is nothing but outerwear. Now what is the limit for outerwear? Color fastness to light test for outerwear? It is 4. So in that case, you can really understand by comparing with this requirement standard and actual what you have found, we can easily take a decision that which one is acceptable, which one is not acceptable in the lot. So for outerwear, color fastness rating of 4 is acceptable as per our observations in US and both non-US based market. Now let us see students, what do you mean by this particular image? What the person is doing? Yes, the person is stretching two parts and there is a seam in between. So that strength is called as seam strength, and that is measured in Instron tensile strength instrument. Seam strength of a garment, it plays a vital role in describing the quality of the material. So seam strength parameter is checked for this, and there is a failure after a certain load and we get the result out of it. Now in the particular this diagram or the particular this kind of bar chart, you can find it out that different market, what is the scenario of dimensional stability as a part of the case study of these tolerance limits of different kinds of garment and for different properties. Now this particular survey was conducted by one of the third party laboratories and they have published this one. Now here you can easily see that how in the minus side, that is the shrinkage side, and the bottom side is the growth side, the particular product has been indicated, both in the case of US market and non-US based market. So you can easily see from this diagram how much beneficial it is to represent this kind of data in this bar diagram kind of thing. So this is applicable for US and non-US test market, and there are certain other parameters are also checked in the case of the case study, that is also called spirality. And we have seen that universally spirality is acceptable at a particular level. All US and non-US based market are in agreement with this. Now in case of tensile strength, okay, in tensile strength also the performance of apparel of different products that has been checked, and it has been found that almost similar result is there for US and non-US based market for different types of apparel products. So they do not vary much. Now in case of the seam strength, what we are talking, this is also very flat structure, and you can see that particular structure is applicable for different varieties of fabric, and almost a flat structure is noted for all the markets, US based and the non-US based market. As we already mentioned, the non-US based market means UK, then Australia. So all these other areas are called non-US based market. So both are all in agreement with this same kind of rating. Now bursting strength, if you take for US and non-US based market, the tolerances and all these things, you can see that little bit of higher tolerance limit is there for bursting strength in case of US and Canada, and it is little lower in case of non-US based market. Now students, there are different performance tests are also there, like color change, colorfastness test, different colorfastness tests are there, and those different colorfastness tests, how is the result in perspiration or in water, all these areas, and this is almost same for all the different kinds of market, US and non-US based market, and normally this color change at the level of 4 is acceptable in the industry and the export market. So let us see, students, if there are other such kind of factors are also there. Yes, colorfastness test, when we talked about the colorfastness change of color, then there is also the color staining part for different types of fastness properties, and we can easily see that there is a difference now. US and Canada, okay, the lower kind of rating is acceptable. There is a tolerance limit is lower rather than the UK or non-US based market. So this has been indicated in this particular bar diagram, irrespective of any kind of colorfastness test performed in the US and non-US based market. Now students, let us see that what is the result of such survey for colorfastness to light. It is an important parameter, colorfastness to light, and it has been seen that for US and Canada, okay, the particular colorfastness to light test, not much difference, 10 hour, 20 hour, but there is a distinct difference is there for non-US based market, okay. So we have to be little careful when people are doing the export, which country they are exporting and which performance standard one must follow for that particular buyer. So that is the result of the colorfastness test. So it is not all these parameters are in agreement with both US and non-US based market. There are certain variations, okay, as is seen here. Now in case of bursting strength, as a student you already know about this bursting strength. What is bursting strength? And this is applicable for knitted goods only, okay. So in this case, what happens, the bursting strength, when you are talking, it talks about the different physical parameters. Abrasion resistance is one of them, and a particular instrument is used for that, that is the Martindale abrasion tester. Then there are flex abrasion testing also is there, similar to this figure. The flexing operation of a particular garment is measured into this abrasion test, and here also not only the damage to the fabric is measured, but also how much color has gone with that damage, that is also measured here in the determination of the end point in the flex abrasion test. Then there are other tests which are also involved into this, that is the flat abrasion. This is a normal abrasion. Since you already know that there are three types of abrasion, one is edge abrasion, one is the flex abrasion, and one is the flat abrasion. So flat abrasion is the normal abrasion, where you can see little bit of threads are coming out, okay, after different cycles and all these things happened in this. So that is abrasion flat or flat abrasion. Now students, when you are talking about such abrasion, there must be some performance standards and their limits are there. What are those limits? What are those standards? Now, when you are talking about abrasion resistance, there is a particular test method which is there in ASTM, and there we talk about little bit on the weight of the fabric and how it relates when you are mentioning the different cycles like 10,000, 15,000. So what is the weight of the fabric? That is also very important. Like 10,000 cycles, 7.5 ounce per square yard Okay. So in that fashion, the performance test is getting benchmarked. Similar situation is for the flat abrasion. There is also one ASTM method has been used. Okay. And there is some specific criteria like 1000 cycles. When it is, then the particular cycle stops, and we measure what is the number of turns are there, or what is the appearance of the material after such kind of cycles, etc. So that is about the abrasion tests. Now, apart from this abrasion test, we talked about little bit on tensile strength also. It is all well known that there is a grab method, ASTM D5034 is there, and a particular instrument is used for that, that is called Instron tensile strength tester. And particular load, when this particular machine works, then there is a damage to the yarn and ultimately it breaks. So that is described in the tensile strength. Now let us see, students, that is there any other tests are also associated with this tensile strength? Yes, that tensile strength, if we want to benchmark, we cannot give a standard material or standard kind of values for that, because it varies depending upon the product, like shorts, pants, jeans, jackets. So there some minimum values are required. Okay. So that minimum value is 50 pound, and if it is blouse, skirt, other dress material, lining, then the standard is around 25 pounds. So in this fashion, you can see that examples that weight of the fabric also plays an important role in this physical parameter testing, as for example the tensile strength. Now students, let us see after this tensile strength what type of tolerance limits are applicable for tearing strength. Now tearing strength, when you are talking, there is a standard test method applicable for this in ASTM D1424, and this is the schematic view of how the tear takes place. A particular cut is there in the garment, and from that cut the tear propagates, and ultimately there is a failure in the garment. So that talks about that tearing strength. Now how it is benchmarked throughout the world? So there is a particular tabular formation, you can see. From this you can easily understand that how it varies. The standards, that the performance standards varies depending on the nature of the product. So that is about the different aspects of tearing strength. Now seam slippage, when you are talking, as we have seen that there is some seam, and if you want to apply force to it or during the normal wearing kind of thing, that particular test is carried out by following ASTM methods, ASTM D434. And different kind of products, you can see that different kinds of standards are there, acceptable standards are there. If it is below the standard, yes, it is not acceptable. So that is about the tearing strength and the seam slippage part of it. Now students, let us see, is there any other parts also involved into this? Seam breaking strength, this is very, very important in the garment performance test. And there is a particular test method which is describing this test, that is called ASTM D1683. And a particular instrument is used, that is called again the tensile strength testing equipment with a specialized jaw arrangement. So seam breaking strength, at which strength or which load there is the breakage of the seam, that is the seam breaking strength. And in front of you, you can see that there is some figures. The seam breaking strength, when we are talking, that what are the different values are there, how much minimum we should achieve, okay, 25 pound, 15 pounds, then depending upon the product, which type of product we are using or testing. Stretch and recovery also is an important factor nowadays, because a lot of materials are available in the market wherein some elastomeric fibers or elastane is used, and this is mainly for the fitting of the garment, okay. So skin fit garments, so stretch and recovery properties are very, very important property for that, and this can be measured in a particular tester, tensile strength tester. So in that fashion also some other arrangements are there by which this particular test can be carried out. Now when you are talking about the seam slippage, the condition of the fabric is like this, that when the slippage occurs, the garment, of course there is some sort of pulling of these threads, you can understand in the stitching areas, okay. So this is called the seam slippage, and we have seen the standards which are applicable. We have also seen the stretch and recovery part of the garment, which can be measured by 3107, and there are some particular standards available for that also. Now students, let us see that we talked about different kind of fabrics so far, okay, woven fabric, knitted fabric, and the garments made out of it, and what are their performance standards in case of colorfastness, durability, etc. Now what about the accessories? Is there any standard for accessories also? Yes. So there are certain tolerance limit and quality standards available for zippers which are used in the garment. As you all know, that zippers, the nature of the zippers, the type of the zippers, performance of the zippers, they all vary. So quality standards may not be same for all. So that you have to understood, and that's why a specified tabular form it is there, and different buyers, they actually have established this kind of tabular form, wherein a test method which is really useful for determining the different parameters of zippers. And what are the different strength characteristics, strength of the zippers at different parts, and what will be the expected value out of it. That is described in these tolerance limit and quality standards of zippers. Now there is also another aspects of these zippers which are used in the garment, that is the different kind of testing areas. If you see the anatomy of a zipper, you can find different places of the zippers are there, slider pull, tab pull, okay. So different areas are tested, and what is their expectations, okay, that in that particular area, what should be the strength requirement in that particular area, that is specified in this tolerance limit and quality standards. Now students, let us see when you are talking about the accessories. So the tolerance limit and quality standards are also available for buttons. As we all know, different types of buttons are used in accessories, and there are a lot of standards available as is shown in the table. In the standards you can easily identify, yes, the different type of visual assessment is done in this, and some sort of structure has been analyzed there, whether there is a crack in the button or not, okay. Now if there is any fastness requirement, that also can be checked in this kind of particular table. So these are the standards available which are different for different buyers. These are the tolerance limits for buttons. Sewing thread, of course, there are the tolerance limits are also there for this sewing thread, different types of sewing thread, and this can also be tested, okay, and how the testing is taken place and what is the standards to be used, that is also shown in this particular table. So these are all the ready reckoner kind of thing, which is actually buyer specific. So buyer actually will determine what should be the tolerance limit for that particular product, okay. because it is all their requirement by which the garment is getting produced. So the different test method, different standards, different tolerance limits, they are all produced or they are all dictated by the buyer themselves. Okay. So here also the sewing thread, very important characteristics, the colorfastness. So colorfastness should not be not less than 4. Now students, you may ask, if it is less than 4, what will happen? Yes, there will be the color bleeding. So color transfer may take place from the sewing thread to the body of the garment. You cannot use this because appearance is getting deteriorated. That is the reason the standards plays an important role to it. So colorfastness to dry cleaning, colorfastness to laundering, okay. So different colorfastness tests, that's why are applicable. Colorfastness to water also plays an important role to it. So 4 is the standard for this kind of sewing thread, very, very important, because you have to wash the garment. You cannot avoid washing the garment. And during the time of washing, if color bleeds from the sewing thread, you can imagine the appearance of the garment. So that's why different performance standards are there to protect that, and we have to abide by that. So students, in this particular lesson 4, it's a very, very important lessons, and it was truly a buyer specific plan or buyer specific tolerance limits, and buyers are scattered throughout the world. US, Canada, then UK, buyers are there in Australia, okay, they are there in China, Switzerland, France. So different places, different buyers are there, what we try to understand, and there are certain kind of tolerance limits are there. Overall, we have seen that tolerance limits are more or less same for US and non-US based market, but there are few changes, okay, or few deviations are also there, okay, in case of especially the physical parameters. Colorfastness parameters, if you see, except that staining behavior, other parts are almost same, but in case of physical parameters or little bit of dimensional changes, there are little bit of variations are there between the US based market and the non-US based market. So colorfastness test, when you are talking, or any kind of durability test or physical performance when you are talking, we talked about both the woven fabric and the knitted fabric. Now we have also seen that accessories plays an important role in the garment. So that's why the buyer specific standards are also there. So also there are tolerance limits for zippers, buttons, etc. Sewing thread plays an important role also during the time of stitching. So all those aspects are getting checked, and there are buyer specific standards and tolerance limits will be available, ready reckoner in the form of tabular form. So one must check the garment and their accessories as per those standards and apply those tolerance limits to know the pass or fail of that particular garment in terms of raw material and accessories. So students, that's all for today for this particular lesson 4, and we will come with a new chapter in the next unit. Thank you very much.